Greetings, I'm Dennis O'Donnell, Vice President of Precision PCB Services, Inc. We have been providing products, services, training, and consulting to the electronics industry for over 25 years. The question we would like to ask today is, when electronic contract manufacturers and product development companies have high-value boards and high-value components, who do they trust to rework these parts, and what equipment do they trust? And my answer to you is they trust Precision PCB Services, Inc., and we use the Shuttle Star BGA rework stations. Today, we're going to do a demo on the Shuttle Star SV560A BGA rework station. And we're going to be reworking a Xilinx XCVU190 BGA chip. For those of you that aren't familiar with these chips, currently on DigiKey, depending on which model you buy of the XCVU190, they sell for $25,000 to $50,000. So we're going to be working a chip today which is in the $25,000 to $50,000 value range, and you don't want to trust these type of chips to just any company or any machine and risk the chance of having them damaged, because that's a lot of money to be out if something should go wrong. So today we're going to be doing this on our SV560. As I said, we're using a 60mm nozzle to remove a 50mm chip. So to begin with, we're going to want to get an external thermocouple under the chip so that we can read our solder ball temperature. So I'm going to bring this out here. I'm just going to put the thermocouple right underneath the corner edge of the chip here, in an area where we won't disturb anything. That way we'll get a reading at the outer solder ball to make sure that the heat's thoroughly heated all the way to the edge of the chip. Next thing we need to do is we need to center our chip in the nozzle. And so on this machine, we're going to press alignment. And then that'll bring our camera system over the chip. The lights are going to turn on, and right now I'm going to have the lights set on low. We can adjust the lights later for the brightness that we want. And then I'm going to focus the chip in the screen. There we go. So now I can read the numbers on the chip. I can turn my lights up and down as I want. I want to have the lights set just enough so that I can see the outline of the pickup tube in the center of the screen. Okay. So next thing we're going to do, what I like about this machine is some machines use a split vision system where you have to split the mirrors. In this machine, the head will move around to each corner of the chip where you would like to see either the solder ball or the chip edge. And so we can just press for the upper left corner, and it'll move to the upper left corner. Basically, I can see my nozzle here and my chip here. We're going to go ahead and we're going to get the chip centered into the nozzle. If we need to, we can zoom in a bit. We got to latch down our board so it's tight. I'm going to turn up the light a little bit more so I can see the nozzle better. There we go. So our nozzle is in a blue light and our chip is using the gold light. We'll straighten that nozzle out a bit. And I'm just moving it so that we'll have a small gap between our nozzle and our chip, because this one's a pretty tight fit. It's a 50mm chip and a 60mm nozzle, so we only have about a 10mm gap there. And so I have to make sure that the gap's even all the way around. So move to our right corner, upper right corner. Now we're going to our lower right corner. And then we're going to go to our lower left corner. Go back up around again just to make sure, but it looks like we have a pretty even gap around the chip. And then we're not hitting any outer components. That's good. So we're all set. Thermocouple's in. I'm going to make sure our bottom nozzle's up just close enough but not touching the board. Everything is lined up, so I'm ready to press our desolder command. Now the nozzle will go back down. The pickup tube will touch the chip, and then it'll back up about, I have it set to back up 3 millimeters. So you're going to go down and touch it. Once it senses the chip's height, it's going to back up 3 millimeters. And now we'll start the profile that we have for this one. See, we have our rapid heat infrared heaters. There are 6 of them, and you can turn them on in sets of 2 to 6. And right now I just have 2, the front and the back, because this is a smaller board. So I don't need to rerun the other heaters that aren't going to affect the board, but I'm running the heaters that are directly under the board. By having the infrared area heaters, this will preheat our board and allow us to not have to use as high a temperature on the direct heat. So basically on this machine we have upper hot air, lower hot air, the focus on the chip area, and then we have an infrared area heater that preheats the board around the chip. Well, basically preheats the overall board. When you do a larger board, you start into boards that are 15, 20, 30 inch or more, you're going to need the area heaters, because especially if they're thick boards, you have to preheat that board in order to get a good reflow temperature at the chips. So right now I'm just monitoring the temperatures, and this is going to be about a 6 to 7 minute profile. This is a new machine, so it's the first time I'm doing this chip on this machine, so it's the first time we're setting up this profile. I have a peak reflow. I have a 5-zone profile, and we're going to try and bring this solder ball temperature up to about 250 C at the solder ball to make sure that there's a good reflow. And so I'm going to monitor my profile in case I need to readjust it at the end to make sure we can save it and then repeat the rework on the same type of boards and same type of chips. Okay, so we're getting about 236 at the solder ball, and I'm just going to put a probe in here and see if the chip is loose. That's great. And so we're reflowing at about 240. Sometimes it takes to 250 with these boards because there's a lot of copper. I'm going to note what my current temperatures are. It looks pretty good. So I'm going to stop it, and it's going to automatically pick up the chip when I tell it to stop. Let me prepare it here. Beautiful. Got a little bit of smoke because we did put some flux under the chip before we started, because if you put flux under the chip, it'll allow the solder to release more smoothly so that it's easier to clean up. Also helps transfer the heat better. So I picked up the chip, set it in the upper nest, and now the cooling fans go on. So what happens is the upper and lower heaters will kick into high speed, and they'll start cooling the upper and lower heaters. We have fans on the edge of the area heaters here, so the area heaters have 4 fans. It'll start cooling the infrared area heaters. And then we have one large fan here that blows across the whole machine and cools down the board. So normally it takes about 2 to 3 minutes to come to a complete cool down, and then you can go on and start reworking your next board. We'll let this cool down for a second, and I'll show you what the board looks like. Very nice removal. Shouldn't be too. That's pretty cool already. And so we can see we had a nice even removal of the chip. The solder balls are nice and smooth because we put the flux on them. So we're going to go ahead and we're going to clean up this board. The customer has requested we do a few electrical tests to debug it. We're trying to find out if the chip is bad or if the board's bad or if it was just a bad solder connection. So we do some defect analysis for our clients. Once we're assured that everything's testing out okay, we're going to reball the chip and put it back on. Because sometimes it's just the solder connection, didn't make a good connection, and if we reball it and reinstall it, then it works. And again, we did not install this chip. This chip was installed by a different company because when we install the chips, they normally work 100% of the time unless there's a defect on the board of the chip. But our process is pretty much a zero defect process that we've developed. And if you purchase equipment from us, we will teach you how to run our process and run our reballing equipment. So that's about it for this part of the video. Part 2 will be reballing and reinstalling. So stay tuned. Thanks for watching.